Algebra 2, Lesson B, perimeter, area, volume, surface area, and sector of circles. We're going to start off with perimeter. And perimeter is, it's simple because we're basically given three sides, or four sides rather, to this shape. And to find perimeter, we're just going to add all four sides. So 3 plus 3 plus 4 plus 2.5 will give us the value of that, which is 12.5 units. Okay? So finding the perimeter is pretty elementary, pretty easy. And again, I think you probably from second grade on down probably have that down pat. Okay? Now, when we get into the other parts of this, it can get a little bit more difficult. But again, review. Let's start with a circle. Okay? So a circle, if we have a half a line here, in your textbook, it's labeled R for radius. Okay? And radius is basically telling us that whatever that is, the equal and opposite would conclude that or finish that. We would call that a diameter. Okay? And you see that on the third circle that's there, where we see that completely finished. Okay? In the middle, we have a circle, and then we have this line that seems to be kind of off-center. It's off-skew. I mean, diameter, of course, we saw as right through the middle. Okay? Radius was half. But this one seems to be kind of like off in no man's land, and we call that a chord. Okay? And again, these are review terms. You've seen these many times. It's just kind of putting them back into your mind again as we go forward. All right. So how do we come up with the difference between a circumference and area of a circle? Okay? Well, circumference is literally circumference, not the equation for circumference, but to come up with this unique thing called pi, we have circumference divided by diameter. Okay, and when we get that, okay, we finally achieve pi, because if we have a circle, and in your textbook you see this circle, okay, with a midpoint. And you see that the diameter, okay, if we were able to take that diameter and I'll put it in blue and take that and go around here, we'd have 1, we'd have 2, and then we'd have almost 3, but we have this little gap here, okay? And that's where pi comes in, okay? So we've solved for pi because a straight line doesn't quite complete the circle. All right. So because you know that, we are going to quickly run through the difference between what a circumference is, okay, what that equals, and what area of a circle equals. Circumference is diameter times pi, or 2 pi r. Area is pi r squared. So what's the difference between the two? Well, if we have a radius of 3, diameter would be a total of 6. However, down here in the area, if we have a radius of 3, that means 3 squared, which is equal to 9. So it would be 9 pi would be our answer for area, and then it would be, for diameter, it would be 6 pi. Those two are different answers, okay? So you have to be careful when you actually are doing these math problems to find out, okay, am I actually after circumference or am I after the diameter, or excuse me, the area? Okay, so moving on, there is on page 12 some examples of how to find areas. And we just talked about circles, but there's also one that is a triangle. This is almost funny, okay? Because 3 times 4, and then what you don't see is that part of it. So it's actually 1/2 base height. Well, base is 3, height is 4. So 3 times 4 is 12. divided by 2, so we have 6 units for a triangle. And that carries true with all triangles, of course, and you know that, okay? But as we continue to march on here, there are several other things that they give us to kind of trick us a little bit, okay? And the first comes with kind of this semicircle looking shape that is maybe a little bit deceiving in our eyes. However, I would like to propose to you that this is actually one of the easiest, okay, problems to do. And here's how, all right? So I look at this as 3 different shapes. Here is the circle, okay? But we're not going to get this part of the circle, okay? Only half the circle. We're going to look at the square or rectangle, which is this part. And then we also note here that we see a triangle. So we're going to look for the circle, or half of it, plus the rectangle, plus the triangle to come up with the area of this shape. And they give us some important parameters, okay? They give us important numbers as far as this is concerned. First, the radius is 2. We note that these are both given as 4. This is 3. This is 5, okay? How do we know the height of this thing? We know that the radius is 2, which means that this is also 2, which means that the height is 4. Let's start with the triangle. 4 times 3 divided by 2, 6. How about this square? 4 times 4, 16. All right, now to the circle. We know that the area of a circle is equal to pi r squared. Well, radius is 2, but 2 squared is 4, so it's 4 pi. So literally we're saying 4 pi, sorry about that, 4 pi plus 16 plus 6, that will give us our answer. And you'll note that the answer is 22.28 meters if you do your math correctly. All right, so pretty simple. Don't get all bent out of shape, no pun intended, when you're dealing with these kind of irregular shapes, because they work. All right, next up, volume. Volume is simply area, but an added dimension. So instead of multiplying 2 things, like if I had a square here, it was 3 and 3, that would mean area is equal to 9 units squared, okay? But what if I have 3, the length 3, and the height 3? That means we're going to have units cubed, because there are 3 values given to that. 3 times 3 is 9 times 3 is 27. So you can see that volume is way different than area, okay? Pretty simple, again, to understand and kind of revisit. Turn the page, and we're going to go to page 14, and they give a couple of examples of all kinds of these shapes, okay? So you have prisms, right cylinders, you got right prisms, you have rectangular, triangular, or irregular, okay? So there are all kinds of different looks at this, and people get really nervous, like, how do I find the area? How do I find the area? Well, just think about this. If you've got a cylinder, okay, it's got 2 circles, right? So you have 2 areas of circles to figure out. And if you unwrap this, it basically looks like this in a schematic. So find out what the rectangle is as far as area, find out what a circle is, and then multiply that times 2, because you have 1, 2, add them together, and you've got your area easily found, okay? So again, break it down into simpler things so that you don't have to worry, am I going to get this right? Is it going to work? Okay? All right. Couple things to remember, okay? In a cylinder, all all right? Here we have a cylinder, all right? And if we drew this up, and you could see this, a cone inside the cylinder, right? Those orange cones that's outside. You would also note that there are 3 in this picture. There's one here, there's here, and here. So a cone is 1/3 of a cylinder, okay? So just remember that. That's what a cone is, okay? Now, what about a sphere, all right? A sphere is unique, okay? A sphere is also found in a cylinder to demonstrate its properties, okay? And there's some voids on all sides of this, okay? And if it's on all sides, we can understand a couple of things, okay? We said that a cone is 1/3, but a sphere is 2/3 of a cylinder. A sphere fills up the cylinder way more than a cone does. And you can actually see that, okay, pretty easily by looking at those two pictures, all right? So whenever we find out the area, we're going to use 2/3 as our multiplier for the sphere and 1/3 as the multiplier for the cone, okay? Again, simple things. You've already gone over these in geometry. You've learned your shapes. You know those. We're just going to use them to apply those pretty easily, okay? So on B.3 or B.3, it gives us kind of this weird shape, kind of I don't know. And then it draws these lines down here, and we kind of see this reshape down here. I'm not going to try to reshape it here, but what they're showing is that this is the volume of a cylinder. So a couple things they give us. They give us the area of this, which is 242 meters squared. They also tell us that the height of this thing is 10 meters, okay? If they've already done the work and found area, all we have to do is multiply by the 3rd dimension, and we can come up with our area. That's what it's asking for. So 242 times 10 is going to give us 2,420 meters squared, okay? But remember, we're dealing with area here, not volume, all right? So we have 2 dimensions that we're still multiplying, so it still remains squared, okay? So pretty easy, B3, not too difficult to come up with that answer for this example, okay? All right, turn the page. We're going to look at a sphere, okay? How do we come up with the volume of a cone and the volume of a sphere, okay? Well, again, volume of a cone, and in the top of B.4, you see this thing, and it was kind of a similar shape where it's kind of got this footprint, and then it kind of comes in and around, and then, meets up here, okay? And you've got these moments coming down here, these lines of direction, and it kind of shows you that this footprint back here is a cone, all right? And it says that the area is 242 meters squared. How do we find the volume? It's also 10 meters high. Okay, well, remember about a cone. We have that thing called 1/3 of a cylinder, all right? So if we had a cylinder here and it was all the way up here, it had that same weird funky shape on top, okay? All those lines would match up, okay? So we have to multiply by 1/3, and then we're going to do the same thing. 1/3 times 242 times 10, because we're looking for volume here, we have to add the 3rd dimension, all right? And again, 2,420 divided by 3 is going to equal our volume, all right? Again, pretty easy, not too difficult to come up with, and we understand the principle behind this task. All right, as far as surface area is concerned, again, when we're dealing with a prism, okay, and probably the prisms are the easiest to demonstrate, okay, and we're going to draw some lines here. Okay, so we want to see the full, every single side and base. If we can think about it, all right, we can try to figure out what that each spot or each shade is. Okay, so whether it's the bottom, whether it's the sides, whether it's the face, every single shade we can actually figure out. And given the information, it's pretty easy. Okay, so we have 4, 3, and we have a slant height of 5, and then a depth of 6. All right, so we know we have 2 end pieces. So 4 times 3 divided by 2 gives us 1, okay, which is equal to 6. But we have 2 ends, so that's 12. Okay, that takes care of the 2 ends. What about this face? Okay, this square right here. Okay, 6 times 5 is 30, and we're going to stay with that because it's a square. All right, what about this little bottom section? Okay, well, 3 times 6 is 18, right? So we're going to keep it there. And then we have to figure out what the back is. The back is 4 high and it's 6 deep. So 4 times 6 is 24. Well, there's our problem. 12 plus 3 plus 18 plus 24. And we'll come up with an exact amount of 84 centimeters squared. Okay, so again, pretty easy when we come up with that kind of number. Oh, that should be 30. Sorry about that. I don't know why I left it 3. So we have that completed and done, and again, pretty easy. Just got to take your time. Don't make mistakes like missing that 0 like I just did. All right. Okay. All the way through this lesson, you're going to see all kinds of adaptations to these things. And because all of them are similar, I don't feel like I need to go any further with the shapes and that kind of thing. So I'd like to jump to page 18, the bottom of page 18, and then look at sectors of circles. Okay? So to show you how we design a sector, okay, we have a midpoint, an array comes out, an array comes out, and whatever that arc is, let's call it 20 degrees, okay, is the same on the inside as it is the outside. So you're going to have questions that say, find the area of the arc, or of the sector, excuse me, all right, which means find the area of the piece of pizza, okay, essentially. And how you do that is you're going to put your known over 360 degrees, and then you're going to multiply that by pi, in other words, the area of a circle, okay? So pi, and then we need to know something. What is the length of this radius? What is that length? Well, let's call it 3, okay? So in order to find pi r squared, we're going to say 3 centimeters, and then that's squared. So it's not a difficult task to see this fraction multiplied by the area because we need the area. Now what the fraction here does for us is it excludes this whole spot, and it gives us the ability to include the segment that we want, the area of the sector that we want, okay? We can do the opposite and find this area, but then what we're going to have to do is we're going to have to take 360 degrees and subtract it by 20, and then that would be our actual fraction. So it would be 340 over 360 times pi 3 centimeters squared. Okay, you can do it both ways, and you'll see it both ways. All right, I think that about does it for this lesson. You guys are going to do 1 through 30. And if you have any questions, go ahead and ask me. Until then, we'll see you later.